Hello, and welcome to Dr. Monroe's Material Science videos. In this video, we're going to be talking about electrons. So, what are they, how do they move, and why do we care? So, an electron is a thing, it's an entity. And we usually draw it as a sphere. And electrons have certain attributes that change the way they will interact with the world around them. So they have mass. The mass of an electron is 9.109 times 10 to the negative 31 kilogram. Now that's really, really small. It's really, really light. But still, it's a particle, and it has inertia. So that means it takes energy to get it moving, and it takes energy to get it to stop moving. Something else an electron has is charge. And the charge of an electron is negative, and the value of that charge is negative 1.602 times 10 to the negative 19th coulombs. Now, coulombs are important because it's actually coulombic forces that will allow this electron to interact with other particles that have different charges. So there are many different particles. There are many different types of entities that are charged, like ions. But inside of an atom, we have positively charged particles, and we call these protons. We have negatively charged particles, and we call these electrons. And we have neutrally charged particles, no charge at all. And these are called neutrons. Now, protons and neutrons, of course, they make up the nucleus of the atom. But how does an electron view a proton? How does an electron interact and view a neutron? So what happens is a proton, positively charged particle, will be attracted to an electron, and an electron will be attracted to a proton. The proton's kind of bound inside the nucleus of the atom, and so the electrons moving around, they're more likely to go towards the proton. Protons and neutrons move towards the electron. But an electron doesn't like other electrons. It stays away from them. And so you have a repulsion between two charges that are the same, two electrons. And a neutron doesn't matter. There's no attraction or repulsion. An electron doesn't really care that a neutron is there. And these things are called coulombic forces. These are the forces that bind an atom together. So these electrons are bound to the nucleus by this coulombic force. But that doesn't mean that they're stationary. So electrons move. They move around. And this movement is caused by heat. So when you think about the temperature, what temperature something is, that's actually how much the electrons, protons, and neutrons are wiggling around inside the atoms of that substance. So that movement, or heat, is what actually gets the electrons to whiz around the nucleus of an atom. And an electron can move in one of two ways. So in one way, it can translate. And translate is exactly what it sounds like. An electron moves from one location to another in a straight line. And that movement is on the order of 10 to the negative 10 meters. That's really, really small. It's on the order of an angstrom. Very, very small movement of an electron. And an electron can also spin. So it can spin about a particular axis. And that spinning motion and this translation motion will affect the way the electron interacts with the world. And it does it in a seemingly surprising way. By translating the electron, you actually create a magnetic field. There's a link between electron motion, or the motion of a charge, and the creation of a magnetic field. So if an electron moves, a magnetic field will be created. And if an electron spins, a magnetic moment will be created. So there's a link between the motion of a charge and the creation of a magnetic field. And we know this to be true because of things called electromagnets. If you have a wire and you shove in electrons over here and they squeeze out the other end, what's created is a magnetic field around that wire. Well, the same exact thing happens with an electron and the way it moves around the nucleus of an atom. So we have charge that creates forces that bind the atoms together. Binds the electrons to the protons, essentially. Then we have movement. That is caused by heat. Movement of those electrons. Now, to describe the movement, we need to understand how the forces are pulling on the electron and why they're bound and how they move around the nucleus. The problem is, the casual observer, if you are trying to see what is happening in the electron, in the atom itself, you're really far away. It's really, really, really small. And so if you have a nucleus of an atom, you can't really tell the exact location of an electron in relation to that nucleus. All you can really say is that this electron will be somewhere around this nucleus, and it'll have a high probability in this specific region right here. But in this region in between, it has a really low probability. So that means the electron's not going to be found in there, but it'll be found in the green ring. So how do we describe this? How do we describe this probability of finding a high probability of finding an electron here and a low probability of finding an electron here? Well, we turn to something that we call quantum mechanics. Quantum mechanics. And in quantum mechanics, you have these really big equations. And what we want to do is for this class, we want to take that big equation and boil it down to very simple terms. And there are 4 very simple terms that will describe how an electron moves around the nucleus of an atom. The first of these is n. N can have a value of 1, 2, 3, or 4. And these might be described in your book as K, L, M, and N. And what this tells us, it essentially tells us roughly the distance between the electron and the nucleus. So if you look at this, this particular kind of electron cloud, if the nucleus is right here in the center, N will tell you the distance between the center and a region of high probability. So this would be one particular N right there, and this would be another particular N right there. So another number that we need to use to describe the way an electron moves around a nucleus is called L. And L can take the form S, P, D, or F. This is the shape of the electron cloud. So if you look over here to the left, this upper left electron cloud configuration is spherical. But this one looks dumbbell-like. And this one would be similar to the S, and this one would be similar to the P type of subshell. So this is what we call the subshell, which tells us the shape of the electron cloud. Another number we need to take into consideration is M sub L. So why M sub L? M stands for magnetic, but it's the magnetism due to the subshell, due to that translation of the electron inside that subshell. So this is magnetism created by the translation of the electron inside that subshell. And the fourth quantum number that we want to take into consideration will be M sub S. And you probably guessed it already. This is the magnetic contribution to the motion of that electron due to the spinning of that electron. So now we have everything that we need to know to describe the way the electron will move around the nucleus of an atom.